Yeah, good morning to one and all. Myself, Dr. S Nagini, working in CRC department of VNR VJIT since past 20 years. And I'm very well versed with subjects like programming languages, computer organization, object-oriented analysis and design, and some more things. But my research area is in data mining related to agricultural sector. But today we are going to learn a topic on computer organization called as how to design an adder, because we understand that addition, multiplication, division or subtraction in a system is only performed through the adder. So, we will just look at the base adder called a half adder, then we will just go ahead and look at what is called as a parallel adder, before which we will be learning about full adder also. Let us see how to design a half adder. When you talk about how to design a half adder, it is like just adding two bits. A bit means here it can be a binary bit, that is 1 or 0. So, how to add two bits? If you are able to design such circuit, then it is called as a half adder. To do this half adder, let us take two variables x and y. X and y are going to take bits which are either a 0 or 1. So, let us take two variables x and y. So, x and y can take two different values, 1 or 0. So, the combination will be like 2 to the power of 2, that we are going to get 4 of them. So, x takes 0, y takes 0, x can take 0, y can take 1. If x takes 1, if what happens if y takes 0 and x takes 1, and so we get 4 cases. To address these 4 cases, we go ahead and start designing what is called as a half adder. So, when you look a half adder, take a half adder into a consideration, we get outcome as sum, sometimes we get a carry. So, the output of this would be a sum and a carry. So, we treat these two variables as input values and these two as output values. So, if you perform sum of 0 plus 0, you are going to get a sum of 0 and there is no carry. When there is no carry, you just represent it as 0. So, it will be like the output will be sum is 0, carry is also 0. But now, if you would like to add 0 plus 1, the output is 1. So, we are going to get a sum of 1, but since there is no carry, we just represent it as 0. Similarly, let us take 1 plus 0 also will produce as 1. The carry, since there is no carry, we take the value of carry as 0. But when it is 1 plus 1, the value that you get is 2. But when you look at 2, 2 is not a binary value, because if you take a binary value, the values will be only between 0 and 1. So, that means 2 has to be converted into a binary format. When you convert 2 into a binary format, the value is equivalent to 1 and 0. At this point, the result would be, the resultant sum would be 0, but the carry will become 1. So, the output of this is sum is 0 and the carry is 1. So, when you derive something like this entire thing is called as truth table, a truth table for half adder. Now, based on this, we start designing the circuit, and first of all we derive the equations, the functional equations related to this. So, let us see, when you look at this particular table, the output of sum and carry is high at two different locations, that is when x is 0 and y is 1, and when x is 1 and y is 0. That means, we take the min term values of these two locations to represent the function. So, if you take f of x, y as a function, then the sum that you are going to derive will be equivalent to, it is the output is high when x is 0. When x is 0 in a min term is represented, x is represented as a complement form and y will be represented in its normal form, and it is also high at this location. But these are the only two locations. We create a min term is sum of products. So, here x is normal form, y is existing in its complement form. Now, when you derive something as x complement y and plus x y complement, it is an XOR operation. So, the gate that you will be using to represent is x exclusive or y. The outcome of sum of a half adder is represented as x exclusive or y. Similarly, a carry is only high at one location. So for input of x and y, the carry is high only at one location, the location when x is high as well as y is high. So the equation, the product term that you will be deriving is x dot y, which is an AND gate. So with these inputs as x and y and some outputs as x exclusive or y and x dot y, the circuit looks like this. So here the x input and the y inputs are going into the circuit, and the sum of these two bits will be an exclusive OR gate, and the output is shown as this. But whereas the carry is shown using an AND gate, because it is just a product term between x and y, and here we derive a carry. So this is the simplest topic called as a half adder, and this is how you derive the circuit of a half adder.